Hi there, my name is Mr. Nyati. I'm back again. It's been a while since I posted a video, an academic video on this channel. We go straight to a question paper, which is 2024 GCE question B5, that is section B of the 2024 GCE past paper. And the question reads, 10.5 grams of sodium hydroxide was reacted with a dilute sulfuric acid according to the equation below. So the equation is written there, and then you have sodium hydroxide plus sulfuric acid to give you sodium sulfate plus water. And the first question, question B5A says, balance the given equation, and there's an allocation of 1 mark. So what we're going to do is to basically rewrite the equation as it is here. This is the chemical equation, and this is how it is. But we need to balance this equation. And so how do we balance it? First of all, we need to copy all the atoms on both sides of the equation. And we know that the atoms on the reactants are the same on the product side. So we are going to copy these atoms and put them like that and indicate the number of atoms. So for sodium, we have 1. For oxygen, we have 4 plus 1 to give us 5. For hydrogen, we have 2 plus 1 to give us 3. For sulfur, we have 1. And by the way, whenever there is nothing after an element, we assume there is a 1. In this case, we have sodium element here. This is sodium hydroxide. This is a compound. But this compound consists of sodium, oxygen, and hydrogen. And so here, just after sodium, we do not have anything. So we assume that there is a 1. There's a 1 for oxygen. There's a 1 for hydrogen. And then we also have hydrogen. Just after hydrogen, there is this 2. So it means that we have 2 atoms of hydrogen. And then we have 1 atom of sulfur and 4 atoms of oxygen. And so when we do the summing up, we have 1 for sodium, 5 for oxygen, 3 for hydrogen, and 1 for sulfur. When we come to the product side for sodium, we have 2. For oxygen, we have 4 plus 1. This gives us 5. For hydrogen, we have 2. And for sulfur, we have 1. And so balancing up this equation means that the number of atoms on the reactant side must equal the number of atoms on the product side. So we start with sodium. We have a challenge with sodium because on sodium side we have 1 atom. On the reactant side we have 1 atom, while on the product side we have 2 atoms. And so we need to balance this up. But for oxygen, we have 5 and 5. So we have no problem with oxygen, but we need to fix the problem with sodium. And as we proceed fixing these problems or balancing the equation, you realize that numbers will keep on changing so that at the end of it all, an equation is balanced. So whenever you have something like this, okay, these are different. So what you do is that, first of all, whenever you have a compound like this one, in the front here, we assume that there is a 1 if there is no number, okay? So we have 1 here, 1, 1, 1. Okay, so when balancing, we normally increase the number of atoms where it is less so that it is equal with the number of atoms where it is more. I don't know whether you are getting that one. In this case, we have 1 here and 2 here. So we need to increase the number of atoms for sodium so that it is also indicating a 2. And we can only do so on the equation by attempting to change the coefficient. Here, remember I said this is 1, this is 1, this is 1, this is where we can change when balancing the equation. We cannot change anything after the element. We can only change the coefficients. So in this case, we have sodium here. We need to look for a coefficient which when we add here, it will give us a number which is equal to 2. Remember there is 1 here. And so what number is that? It is 2. So when we add 2 in front of sodium here, it means that we can now say 2 multiplied by 1, which is invisible here, which we have assumed, and it will give us 2. So we are saying 1 times 2 to give us 2. Okay? Now this 2 has not only affected sodium, but it has also affected oxygen and hydrogen. So we now have 2 oxygen and 2 hydrogen. What does that mean? It means that for oxygen we need to change here because we have 2 for oxygen and this 4 for oxygen on the reactant side, which gives us a 6. For hydrogen we now have 2 because remember this is the whole compound and this 2 stands for every element in this compound. So we have 2 multiplied by 1, we have 2 for hydrogen plus 2, which gives us a 4. And we still have a 1 for sulfur because we have not changed anything on sulfuric acid. So we go back again. We now have 2 atoms of sodium, but we still have 2 atoms. We also have 2 atoms of sodium on the product side. What about oxygen? Oxygen, we now have 6, but we have 5 on the product side. What do? At this point, we also need to consider hydrogen. Remember, hydrogen has 4. Here it has 2. So we also need, because this is the one which we can easily change, unlike oxygen and on the reactant side and on the product, which has a difference of 1, 6 and 5. But this one which has a difference of 4 and 2, it is easy for us to balance. And let me also emphasize, when you are balancing, go for those that have a difference of 1 and 2, 2 and 4, and so on and so forth. So in this case, we need also to add a coefficient in front of water, which is going to help us have a 4, that is number of atoms of hydrogen. So if we add a 2 here, it means we now have a 4 for hydrogen. But this 2 has not only affected hydrogen, it has also affected oxygen. So what does that mean? We have 2 on the product side, oxygen, and the 4. So we add this, it gives us 6. Let's go through. Sodium 2, sodium on the product 2, oxygen on the reactant 6, oxygen on the product 6, hydrogen on the reactant 4, hydrogen on the product 4, sulfur on the reactant 1, sulfur on the reactant 1. The equation is now balanced. This is now a fully balanced chemical equation. We move on to the next question. The next question says, that is B, Roman numeral 1. Use the balanced chemical equation to calculate the mass of sodium sulfate. Now, on this one, we need to be very careful with this question because this part now requires us to use what we call the mole ratio, the numbers that we have used to balance the equation, or the coefficients on each of the compounds. Those are the ones we're going to use to balance the equation. And read the question. The question says, use the balanced chemical equation. What does that mean? It simply means that then the coefficients are going to play a role in calculating the mass of sodium sulfate produced. So in this case, we're going to go with finding out the mole ratio. What is the mole ratio what we are looking at here is that we are looking at what we have been given, the mass. Whose mass have we been given, and whose mass is the question demanding that we should calculate? So in this case, we have sodium hydroxide, whose mass we've been given, and we also want to calculate, as dictated by the question, the mass of sodium sulfate. So we are going to look at the mole ratio for those two. So we pick sodium sulfate, sodium hydroxide and sodium sulfate. Those are the two that we are going to deal with, because we have been given the mass of sodium hydroxide, but we have not been given the mass of sodium sulfate, and that is what we're supposed to calculate. So what is the mole ratio? We have a mole ratio of 2 to 1. In other words, the equation, when you are balancing the equation, when you look at this, we have a 2 here and we have a 1 here. So this is what we are going to use to calculate the mass of sodium sulfate. We proceed. So the mole ratio is 2 to 1. Now, when you calculate the relative formula mass for sodium hydroxide, it is going to give you 40, because sodium has 23 plus 16, that is going to be 39 plus 1 for hydrogen, that is going to be 40. Now, on this side, we are going to have, if you do the calculation, that is 2346 for sodium, and then 32 for sulfur, and 64 for oxygen. When you do the math, it will give you 142. So now, why am I saying all this? Because the coefficients that we used, we are going to use these coefficients to multiply by the relative formula mass, which you normally call the relative molecular mass. Okay, we're going to multiply this 20 by, this 2 by 40, which is going to give us 80. Here we have 1, and so we're going to say 1 multiplied by 142, and it is going to give us 142. So this is what we are going to have. Now, at this point, in calculating the mass for sodium sulfate, we are going to say, but what mass have we been given for sodium hydroxide? We've been given 10 grams, 10.5 grams. So from here, we'll say 80 equates, it should be grams here, 80 grams, having calculated the relative formula mass. Remember, a relative formula mass has no units, but we are going to put grams here so that it becomes favorable during our calculations. So if 80 can equate to 142, this is 80 for sodium and 142 for sodium, 80 for sodium hydroxide and 142 for sodium sulfate. What about the 10 grams, 10.5 grams of sodium? What will it equate to? We don't know. This is where the math begins. And what we're going to do at this point, we're going to say 80 is equal to 142. What about 10.5, which is going to be equal to x? Then you do the math there, you cross multiply, and this is what you are going to have. What you are going to have is x will be equal to, because we've allowed x to be the mass of sodium sulfate. So x is going to be 10.5 grams multiplied by 142 divided by 80, and this is going to give us 18.6375. Now 18.6375 is the mass for sodium sulfate, but remember, you need, because this is the final answer, so you are supposed to basically round this off to two decimal points. Okay, and you round it off, it will give you 18.64 grams of sodium sulfate, and this is the answer. This becomes the answer to the question which was saying use the balanced chemical equation to calculate the mass of sodium sulfate. Now, the last question says, which is question B2, what type of reaction is involved in this equation? Now, the first question you should ask yourself is that what is sodium hydroxide? Now, sodium hydroxide is a base. what is sulfuric acid? Sulfuric acid is an acid. Now, whenever you have a reaction between a base and an acid, what are the products? What are the products? Yes, what are the products? Okay, that is correct. The product is a salt and water. Now, what type of a reaction where you react a base and an acid to give you a salt and water only? When you go back to the characteristics of an acid, the first characteristic is that acids react with reactive metals to produce a salt and hydrogen gas. Another one is that acids react with carbonates to produce a salt, carbon dioxide, and water. And then the third one says that acids react with bases to produce salt and water. And this type of reaction, where an acid reacts with a base to produce salt and water only, is referred to as neutralization reaction. Neutralization reaction. We call this type of reaction as neutralization. Neutralization reaction. Why are we calling it neutralization? Because you are neutralizing an acid using a base to produce a salt and water. So the reaction is referred to as neutralization reaction. Colleagues and learners, I hope this has been helpful, and I hope you are going to press on the subscription button and like this video, share it if possible, so that whenever a new video is uploaded of this kind, you will be the first person to receive it. And I definitely hope that this was helpful. Thank you.